Okay, so here we are talking about rhombuses, rectangles, and squares. Now, all of this is going to be built on the foundation of parallelograms, so if you haven't explored those, make sure to check those out first. I have a few videos you could check out. Now, there's a definition in here as a parallelogram with special properties, but I like to summarize just a rhombus as an equilateral quadrilateral. In other words, any figure with four sides where the four sides are all equal or all congruent. Okay, and that's shown up in the diagram. You've got four sides, and all that we know is the four sides are congruent. I like that two-word definition, really clear. Similarly, a rectangle is an equiangular quadrilateral. So in other words, any four-sided figure where all four angles are equal. And we know, since the total interior angles of every four-sided figure is 360 degrees, then four equal angles totaling 360, we just divide 360 by 4, and we get that every equiangular quadrilateral has to have four 90-degree angles totaling that 360. A square is just a regular quadrilateral. In other words, a quadrilateral where all the sides are equal and all the angles are equal. So you have those four 90 degrees, that makes it a rectangle, and you have those four congruent sides, that makes it a rhombus. And so a rhombus and a rectangle, both those properties make a square. So we go down here. Here's the little Venn diagram that helps me. This is in terms of sets and subsets. In this class, we're going to actually do a project regarding this. But the idea here isn't what do these things have in common. Like, we don't say, you know, cats and dogs have in common the fact that they are, you know, four-legged, that they have hair, things like that. That's not the type of Venn diagram we're talking about. We're talking about the type of Venn diagram where we'd say, okay, here is the space of all mammals. So every dot I put in here, that's a mammal. Another dot, that's an example of a mammal. So I could put a circle in here and say this is the circle of all cats. And then little circles of this type of cat, that type of cat, right? I could put a circle of here's all the dogs, but those two circles can't overlap. There are no animals that are both a cat and a dog. So those are two totally separate spaces. However, I could put, you know, something in here like these are Labradors in dogs, and then I could, overlapping with that category, have brown dogs. Because there are some dogs that are brown and Labradors. There are some Labradors that are not brown, and there are some brown dogs that are not lavender, or Labradors, not lavender. Okay, so that's why I wanted to show you this picture here. This Venn diagram really tells me a lot about properties. Like, I know, for example, if I put a dot in here, that's an example of a square. And every square is in the ellipse of rectangle. So every square is a rectangle. And that dot is also in the rhombuses. So now I know every square is a rhombus. Every square is a rectangle. And all of those are in the parallelogram space. So this is, for me, a very clean visual way to organize all the shapes. Let's go down now and just kind of look at some alternate definitions here. So we can use the diagonals to define our shape. So we have a couple different definitions. Now, I just told you one. We have, this is the normal one, a four-sided figure where all four sides are congruent. That is a rhombus. But we could also say a rhombus is a parallelogram where the diagonals are perpendicular. And you might say that seems kind of weird. Now, we could, if we wanted to, just use our properties from before. We'd say, oh, you know what? If it's a parallelogram, its diagonals get bisected. And if that's a 90-degree angle, well, then this is 90, this is 90, because those lines are perpendicular. And now we could say by SAS, all four of these triangles are congruent. And that would mean that all four of the sides are congruent. So you can see how we could quickly prove that this is a rhombus using that. Same thing here, a parallelogram where the diagonals bisect the four angles. Again, we could say, okay, well, how does that help us? Well, I know that opposite angles in a parallelogram are congruent, and so if it's bisected, every angle is cut in half, so this angle would be half of the whole angle, and this would be half of that same whole angle. So those two angles congruent would make this an isosceles triangle. Same thing over here. And we know that opposite sides of a parallelogram are congruent. Every side ends up being congruent through some transitive property. Okay, so you can see how those do prove it's a rhombus, and if we have a rhombus, we can necessarily prove those two. So it's a biconditional. Okay, so we also have a rectangle, which we could have as an equilateral or an equiangular quadrilateral, or the 490-degree angles. That's the more normal common definition, but we can also say it's a parallelogram with congruent diagonals. Now, over here, what that would mean is we already knew that diagonals bisect each other from the fact that it's a parallelogram. But now we know, since the diagonals are congruent, that all four of these halves are congruent, which means by side angle side, these two triangles are the same. And in this isosceles triangle, we get all four of those angles are the same. Same isosceles triangle, same base angles. We could do the same thing with the top and bottom triangle, and what we realize is that all four of the angles are made up by a combination of these two angles. I'm just in blue. So all four end up being an angle from this isosceles triangle and a base angle from this isosceles triangle. So we can show quickly that all four angles are congruent. So these are alternate definitions of our two shapes. These are really useful properties. And then a square is simply something that's both a rectangle and a rhombus. So what I'm going to do now is just kind of with a flow chart, just organize these properties for you. A square is a four-sided shape that has all the properties of all three rectangle, rhombuses, and parallelograms. It has no advanced special properties of its own that don't come from one of those, but it has all the properties of rhombuses, all the properties of rectangles, and all the properties of parallelograms. So drawing an arrow down here, we have the properties of a rhombus is it has all the properties of a parallelogram, and additionally, it has four congruent sides. And then those things we were talking about, these three are just the definitions from up here. So these three additional properties are four congruent sides, diagonals bisect all four angles, and the diagonals are perpendicular. Okay? Whereas a rectangle has the properties of a parallelogram, except it has four 90-degree angles, which are all congruent, and it has congruent diagonals. Put those together, and you get the properties of a square. And then finally, what we've done in the past is looked at the properties of a parallelogram. So I just listed those again. Hopefully those are something you've already had some practice with. Okay, so we're really adding these 5 properties into the game here. Okay, so let's actually go ahead and use this a little bit. All right, so down here we've got for any rhombus, JKLM. So I'm just going to draw a rhombus. And for naming, we start at any point we want, J, and then we have to go around the shape either clockwise or counterclockwise. We can't just throw letters anywhere. We have to go in order. So JKLM. It tells us it's a rhombus, so I'm just going to start with a regular definition of opposite sides congruent, although we know a lot more than that. And it says to say whether these things are always or sometimes true. They don't offer never, but always or sometimes. So let's look at this. Okay, so let's start with number 3 and pick. So is angle L congruent to angle M? That's a good question. Well, we know, because this is a parallelogram, right? It's just a special parallelogram. We know that there's a 180-degree turn from going to this parallel line to this parallel line. So for number 3, we know the angles are supplementary, but we don't know that they have to be congruent. They would only have to be congruent if this thing was a rectangle. Then it would have 4 congruent angles. But as of right now, parallelograms just have opposite angles congruent, and then the consecutive ones are supplementary. But this will sometimes be true, as this parallelogram could have any 2 angles there that add up to 90, and it is possible to get 90 plus 90 equals 180. So yeah, this would be sometimes true that they're congruent. Okay, let's look at number 5. JK is congruent to KL, so JK is congruent to KL. Well, yes, by definition, a rhombus is a 4-sided figure with all sides congruent. So 5 would be always. Okay, now a different color, let's look at number 7. Number 7 is, JL and KM. So JL would be the diagonal here, and then KM. So KM is the other diagonal. Is it true that diagonals are congruent? Well, let's look up at our properties. No, that's not one of them. That would that would be diagonals are congruent for a rectangle. That would mean you had something standing like this, where one diagonal was much longer than the other, and then you pulled this shorter and tilted until it was straight up and down. That's when the diagonals would be congruent. And then if we started to tilt it the other direction, all of a sudden we get, that was a terrible parallelogram, we get this other diagonal growing and the first one shrinking. So the diagonals are only congruent when that bookshelf is not wobbly but standing straight up and down. So this would only be sometimes. And again, that sometimes is if this rhombus happened to be a square or happened to be a rectangle, which would actually happen at the same time. Okay, so let's do one more out of the book and then we'll jump over to IXL. So the one more out of the book is we have a square, and all it tells us is the side length of 1. So what I want to go through with this square is I want to figure out every possible thing that we can figure out here. So I know if it's a square, I'm going to switch colors here. Let's go with, well, I know that the 4 diagonals, are bisected, right? That comes from the properties of a parallelogram. Okay, so I know this must be 1 over here. But I also know the 4 diagonals are congruent for the 2 diagonals, are congruent. That comes from the properties of a rectangle. So I know this other one is congruent and bisected, so these must be 1. Okay. And then separately over here, I know, let's look at some angles. Well, I know that there's 4 right angles, right? That comes from the fact that a square is a rectangle, so I know these are 90. I know that the 4 angles are bisected by the diagonals. That comes from the rhombus, right? So that means this is 45, 45, because each of those 90-degree angles is split in half. And keep in mind, this is true about every single square. Every single one has 90-degree angles cut in half to be 45 each by the diagonals. Okay, what else do I know? Oh, and I know the diagonals are perpendicular, and that's again from a rhombus. So I know these are all 90 degrees. Okay, so that's all the angles in the picture. However, we got one more missing side, and I'll use another color for this one. How do we get this missing side? Well, this is actually a 45, 45, 90 triangle with our original 1, 1, root 2. So we could just say all these sides are root 2, or we could use the Pythagorean theorem. So we get those outer sides by using Pythagorean theorem, or we remember 45, 45, 90 triangles, either one. And so that would answer all these questions, 45, 47, 49, that you have on your homework today. Okay, so that's just kind of playing with it. What I'm going to do really quick is jump over to IXL and do some practice on these. Okay, so here we are in N5. This is properties of rhombuses. Then we'll jump over and practice some rectangles and squares. So what do we know about a rhombus? Well, we know that the diagonals are perpendicular. So we know these are all 90 degrees. We also know that the 4 angles are bisected by the diagonals. Okay, so if we know that, we can go back here and say, all right, well then this must be 54. And we know opposite angles are congruent, and that's because this is a parallelogram, right? And so we know that this angle over here is the same 108, and it's been cut in half, so 54, 54. Okay, I haven't even looked what angle they're asking for now, but that only leaves really one unique angle. I know in this triangle I could figure out that 180 minus 90 minus 54 will give me my remaining angle over there, which is 36, and then that will end up being bisected, so here's 36. And then the opposite angle congruent and bisected, so each of these is 36. So what is GJK? GJK would be 36 degrees. All right, let's do another problem. Okay, so this one, we want to find what is SUT. Well, I know that all four sides of this shape are congruent, so that means this triangle right here is isosceles. So I've got an isosceles triangle with a 118 degree angle, which means the base angles are congruent. So I would take 180 minus 118 and get a remainder of 62. And then I divide that by 2 to find out that each one of those angles was 31. They add up to 62 and are equal. Okay. All right, so what we're going to find is a lot of similar problems. This one is bisected in a rhombus, so we get 33, 33, 33. Perpendicular diagonals, so we're going to click down here, perpendicular diagonals. So we just need to find this one missing angle here, and then it'll be the same in all four. So 180 minus 90 minus 33, that gives us 56. So we get a 57, I'm sorry, 57, 57, 57. Okay, and so what's it asking for? UTW? Yeah, that's 57. Okay, so I'm going to switch over now and practice some squares and rectangles. So here's N6 now. Let's see. It's a square. What is CE? So in a square, we know it's a parallelogram. So the diagonals are bisected. So if this is 16, so is this. And CE total then would be 32. So quadrilateral is a square. What is measure of angle DFG? Well, in a square, we know that it's a rhombus. So, sorry, not drawing. That is odd. My pen is not working. There we go. Okay, so we got 4 right angles in the middle. We had a right angle here, but because it's a rhombus, it's split in half. So we know each of these is 45 degrees, and all the way around that's the same. So angle DFG is 45 degrees. Okay, so this is a square. What is XZ? So again, this is 34 and 34, so we get a total of 68. Okay, what is the value of, so now we got to say, okay, well, opposite sides are congruent in a parallelogram, but in a square, we additionally know that every side is the same like in a rhombus. So 7W equals W plus 54 minus W gets 6W is 54 dividing by 6. We get that W is 9, and then making sure it could be asking for the side length, but it's asking for W, so we get 9. Okay, so I'm going to stop there. I hope you guys enjoyed the video. Go ahead and practice on your own.